Our topic this morning is retaining operator knowledge and why that's important, and an example of how we're doing that at one of our sites. So the key point here is experienced operators are retiring at record rates, and they're taking a lot of knowledge with them that you're not going to find in an operating manual or operating procedures. So this is an example of how we're taking that data and then making it available to the operators, digitizing it plant-wide and in real time. So a little bit about LyondellBasell. We're a diverse company, both in products and people, and one of the world's, well, we're not a household name, we are one of the world's largest plastics, chemicals, and refining companies. All right, so the problem. The average retirement age is 61, 65. Our retiring operators, console operators, usually average around 35 plus years. In fact, in the last 2 months, we've had 4 with over 40 years retire. And these people are your expert, your process experts. That's the knowledge they're taking with them out the door. In fact, at one site in Channelview, we've had 60% turnover just in the last 5 years. So essentially, that's conservatively, that's 4,500 plus man years that just left. And some of the problems with inexperienced operators are we have a lot of APCs in our plants, and most of these newer guys or girls, they don't necessarily know how to run the plant without the DMCs on, right? APCs. The other thing is a lot of them, we got turnarounds, you're pushing 7-10 years, they've never been through a shutdown or a startup. Some haven't even seen a reactor catalyst change out in startups. So there's a lot of things they haven't seen. So basically, some of the errors that are typical for an operator fall into 3 different categories. One is decision errors, skill-based error, and perceptual error. Now, typically they're going to fall in the top or the bottom one for the less experienced operators. The middle one is more of somebody just on autopilot. They've been doing it for a while and they're just doing routine stuff, and they just miss it, right? So how do you get that knowledge, and specifically what are you going to extract to make this a success? So we focus on the alarms because if you look at the alarms, basically they kind of dictate what your process operating envelope is, what your normal operating conditions are. That's what the alarms are there for when you start deviating from the normal. So that information is in most of your sites in the form of alarm rationalization and your alarm documentation. For us, when we started looking, we did a gap analysis, and we realized we had only about 70% of that complete. There's a lot of reasons for that. Over the years, we've done DCS upgrades. The master alarm database was kept, in some cases, in spreadsheets or older software that didn't survive the transition to our current software that we operate on. The second part was the implementation plan. This is a site-wide effort, and this is literally over 70,000 alarms that have to be documented. So how are you going to do that? How are you going to get the resources, and what's the plan for how are you going to manage all that? And then, of course, you have to sell it to the management side. So this is the plan. Basically, we started with our alarm software, which is Plant State Suite. We export the database into a spreadsheet. We format it for operators because they're the ones going to be inputting the data. And then as for a division of labor, we separated out the system alarms, configuration alarms, that type of stuff, and gave those to the control side. The other process alarms that have to do with the process, we gave all those to the operators And when I say operators, these are the ops specialists. Essentially, we have 13 for the different sites that we have. And we chose to use Microsoft Teams because it has the capability to have 24/7 access. You can do co-authoring for it. And we wind up with about 20 different spreadsheets that they're basically granular down to the console level for those specific operators. There's probably about 210 people now that are contributing to this effort. We're not completely done yet. Also on a weekly basis, and last point there, you have to have somebody that's managing the control, the quality control, right? So the ops specialist is the one that does that. The operators fill in the information. When they get done, they check a box. That flags the ops specialist to go review the documentation and approve it. Once it's approved on a weekly basis, then we import that into our software where it's immediately available to the operator. And I'll show you how they'll get that information in just a minute. And then, of course, to keep this going, you have to have a weekly progress report. We chose for this project, in any given site for any given person, if you have 10 or 12 goals you're trying to accomplish for you, the reality is you're not going to get to most of them. You may get to one or two. So we chose this goal as one of our top goals. And then when you do that, then you also have to come up with a leading and lagging indicators. And then we meet on a weekly basis. That's with the stakeholders, and that's just to keep the accountability going and to provide updates and see how we're doing on a week-to-week basis. So what does that look like? This is an example of our plant dashboard. There's essentially 7 main operating areas. The red bar there is where we should be at this point in time, and the bar there is where we actually are. So you can quickly take a look at it and say, okay, we have some problems in the 5th and 6th one there that we need to look at, and we kind of talk about this in our weekly meetings. But the problem with this dashboard, it doesn't tell you on a week-to-week basis if you're winning, right? So we developed another scorecard, and this is one we look at on a week-to-week basis with all the key stakeholders. So there you see in the blue dotted line is the projected path for the site-wide, and then the dots there are the milestones for each plant when we determined they should be done. And this was based on how many they had to do, and then on a minimum amount that they would do per week, and how many weeks they would take to get completed. So you can see from that we have a couple of plants that are done, and we're still on track. We're ahead of the dotted line. Now, if you drill down further, you can see this is one of our best plants as far as getting the progress done. They actually got done in about 11 weeks, and we had estimated they would get done around 38 weeks. So one of the key drivers for this success is there's 2 ops specialists there, but they opted to empower all their console operators and even some of the outside operators to participate in this effort. So they were ganging up on it, and they got done pretty quick. Of course, if you have this, and you also have the inverse, right? Some of them aren't quite there. And those are, when you look at some of the issues with some of those, as you start talking to the ops specialist responsible for this, and what's the major problem? What can we help with? As well, we don't really trust our operators because there's a lot of inexperience out there. So you kind of eye-opening because you think, well, wait a minute, it's not like they get to choose which alarms they get, right? So they're getting them anyhow. So they're finally getting on board and getting more people on board. So the payoff, what does it look like? This is a faceplate on the DCS. So from the faceplate, there on the bottom, it's a PSS object, synergy object. Basically, it opens up a URL to a real-time server where all the alarm data is hosted. So from that button, you can quickly see that this information tells you the current state. The class of alarm is an IP or general alarm or SCV. The cause, consequence, and corrective action. And they can get this from the alarm summary or a faceplate. And it doesn't have, the point doesn't have to be an alarm. We have native alarm help built into some of our DCS, but the problem is you don't get this information unless that specific alarm is active. This one, they can click from a drop-down box and they can pick any alarm at this point, and it'll give them all the alarm documentation. So far, we've documented more than 40,000 alarms, and some of these are just cleaned up descriptions, old tags that are just never got demoed out of the system. The good thing about this is a lot of this is getting done on graveyards when the operators have more time, and you talk to them, what they're doing is they'll gather around 1, 2, 3, or 4, and they'll actually talk about the alarm and some of the causes, which is probably the most important part, the most likely cause, right? Because you have to know that to go troubleshoot. Now, there were a few things that were kind of eye-opening initially when you start looking at them. For the cause, there was one specific person, it didn't get to the quality control, but he was telling me about it, is they said, what's the cause of this alarm? And I said, well, because it exceeded the alarm trip limit, right? And so it took a while to convince them that wasn't the right answer. And the way we got there is, okay, so let's say on a DP, if you have a high DP alarm limit, the corrective action would then be to raise the alarm limit, right? He goes, no, that's not gonna fix it. So I think we finally made the connection there. So we've got good feedback from the operators, and the payoff additionally is not only is it available to the operators, it's available site-wide to anybody doing a HAZOP or control engineer, process engineer site-wide. So it's got visibility throughout the plant. So just a few acknowledgements here. So thank you.